Hello, my name is Buzu Aisha. This is Hello, my name is Buzu Aisha. This is COSOC presentation. So question one says discuss local search algorithms in relation to artificial intelligence, providing a scenario where each of the algorithms would come handy in solving our daily social problems. One, hill climbing. Hill climbing is a social algorithm, search algorithm which Hello, my name is Buzu Aisha, and this is my presentation. Question one says discuss the following local search algorithms in relation to artificial intelligence, providing a scenario where each of the algorithms would become handy in solving our daily social problems. One is hill climbing. Hill climbing is a social algorithm, such is a local search algorithm. Holy Ghost. Hello, my name is Aisha Buzu. This is COSOC presentation. Question one says discuss the following local search algorithms in relation to artificial intelligence, providing a scenario where each of the algorithms would become handy in solving our daily social problems. Number one is hill climbing. Hill climbing is a local search algorithm which continually moves in the direction of increasing elevation to find the highest point or best point to the problem. It terminates when it reaches a peak value where no neighbor has a higher value. An advantage of hill climbing is that it is simple, intuitive, and easy to understand and implement. A disadvantage is that it can get stuck in local optima, meaning that it might not find the global optimum of the problem. Local optima is like settling for a good enough solution, but not the best solution. So because of this, it does not explore the search space thoroughly, which can limit its ability to find better solutions. A scenario of this is of hill climbing. One which hill climbing search algorithm um, can become handy in solving daily social problems is in optimizing traffic flow in a city. It can be used to adjust traffic light timings to minimize congestion. It by making small changes to the timings and evaluating the traffic, the resulting traffic flow. More time. Hello, my name is Buzu Aisha. This is my COSOC presentation. Question one says discuss the following local search algorithms in relation to artificial intelligence, providing a scenario where each of the algorithms would become handy in solving our daily social problems. Number one is hill climbing. Hill climbing is a local search algorithm which continuously moves in the direction of increasing elevation to find the highest point or best solution to a problem. It terminates when it reaches a peak value and there is no neighbor with a higher value. Um, an advantage of hill climbing is that it is simple and intuitive, it is easy to understand, and it can also, implementation of it can be done in a wide variety of optimization problems and also complex constraints. A disadvantage of hill climbing is that it can get stuck in local optima, uh, meaning it might not find the global optimum of the problem. Um, so it does not. Hello, my name is Buzu Aisha, and this is my course of presentation. Question one says, discuss the following local search algorithms in relation to artificial intelligence, providing a scenario where each of the algorithms would become handy in solving our daily social problems. Number one is hill climbing. Hill climbing is a local search algorithm which continuously moves in the direction of increasing elevation to find the highest point or the best solution to the problem. It terminates when it reaches a peak value where no neighbor has a higher value. Uh, a simple explanation or demonstration of hill climbing is hill climbing itself. When you go hill climbing, there are smaller hills before you reach the peak. Now, hill climbing works in a way that once you reach a smaller hill, that's it. It does not necessarily explore higher, more ground, especially if the neighbors have lower values, which are lower ground. Hello, my name is Buzu Aisha, and this is my course of presentation. Question one says, discuss the following local search algorithms in relation to artificial intelligence, providing a scenario where each of the algorithms would become handy in solving our daily social problems. Number one, hill climbing. Hill climbing is a local search algorithm which continuously moves in the direction of increasing elevation to find the highest point or the best solution to a problem. It terminates when it reaches a peak value where no neighbor has a higher value. An example of that is hill climbing itself. When one goes hill climbing, there is usually smaller hills before one reaches a peak, like the hill peak itself. So hill climbing works in a way that once it reaches those smaller hills, it usually terminates instead of continuing all the way to find the actual peak. An advantage of hill climbing is that it is a simple and intuitive algorithm. It is easy to understand and implement. Disadvantage is that it can get stuck in local optima. Local optima is that small hill, which is not necessarily the peak of the hill of the climb. Um, so getting stuck in local optima means that it might not find the global optimum of the problem. Um, it does not explore the search space very thoroughly, which limits its ability to find better solutions to a problem. A scenario of this is optimizing traffic flow in a city like Kampala. So hill climbing can be used to adjust traffic light timings to minimize congestion. By making small changes to the timings and evaluating the resulting traffic flow, the algorithm can gradually improve overall efficiency. Number two, simulated annealing. Simulated annealing is inspired by the annealing process in metallurgy, where a material, say glass, is heated and then slowly cooled. Yeah. So it allows the algorithm to occasionally accept solutions that are worse than the current solution, which can help it avoid getting stuck in local optima like hill climbing. A scenario under which simulated annealing would become handy in solving our daily problems is in scheduling complex events like conferences or festivals or speaking engagements generally. So simulated annealing can be used to assign speakers to time slots and venues while considering factors such as the speaker's preferences, the audience overlap, the room capabilities, the audience. Yeah, so by accepting suboptimal solutions during the early stages of the process, the algorithm can explore wider range of possibilities and find a more globally optimal solution. Number three is genetic algorithms. These are a class of optimization algorithms inspired by the principles of natural selection. They are useful for solving complex optimization problems where the search space is large and intricate. Yeah, a scenario under which it can be handy is designing optimal routes for delivery vehicles. So, question 1B says discuss how you would improve the usability of these algorithms using responsible AI and explainable AI. So, to define responsible AI and explainable AI, we have to understand what they are. To explain them, we have to understand what they are. So, in explainable AI systems provide clear and understandable explanations for the AI actions, decision making, and all. And then responsible AI incorporates um, human values and human core values in the operation of AI systems. That is responsible AI. So to improve the usability of these such algorithms using RAI and XAI, there are moral principles that are sensitive to human values, which have to be taken into consideration. These principles are embedded in the core principles of RAI and XAI, some of which are these fairness. A system has to be fair in its operation. Transparency, there has to be availability of information to guide usability. Responsibility is the system responsible and sensitive to human interaction. Accountability, can the system be held accountable? Is it possible that the system can be modeled to provide accountability in its operation? Autonomy, adaptability, interpretability, explainability, all these are core principles that can be embedded in the process to improve the usability of these algorithms. Um, Question 2A says define adversarial search. Discuss any two scenarios where adversarial search would become handy in your daily life. Adversarial search is a search algorithm used in game theory where two opposing players in an environment take turns uh, making moves. An example of this is like soccer, chess. I don't know how to play chess. Uh, there's a game called Tic Tac Toe, which is mostly played by the Western world. Um, so adversary research is going from the word adversary, like not friendly. So scenarios under which adversary research would become handy in our daily life. One is in negotiations. Um, in negotiations, adversary research can be used to model strategies of opposing parties. For example, if you're negotiating a contract or negotiating a certain price for a product, adversary research comes in handy in a way that it can be used to model strategies of opposing of the other party, yeah, to determine the best possible outcome for each side. Yeah, so if it's a contract, every party will be able to negotiate based on what's best for them, and then one outcome will be one solution will come out of it, which is the best for each of the sides. So that's one scenario where adversary research can be applied. Another place where adversary research can be applied is cybersecurity. Cybersecurity is a new concept. It's not a very old concept in our operations, especially because of the evolvement of technology. So, adversary research can be used to model strategies of cyber attacks and develop defense strategies to protect against attacks. Some of these are, for example, pen tests. There can be like internal pen testing to model strategies in a way that one can anticipate their opponent's actions and then sort of predict their attacks and be able to counter them. Yeah. Um, Question 2b says, with examples, discuss the minimax and expecti-minimax algorithms as used in adversarial search. Now, minimax algorithm is